Hello friends, myself Dr. Deepa Israni. I am going to discuss the topic that is conduction of nerve impulse. First of all, what is neuron? Neuron, that is structural and functional unit of the nervous system. Neuron, it is composed of dendrite, cell body and axon. Now how the electrical signals are transmitted over here? Now here at dendrite and cell body, it receives the signal from the neuron and it generates the gradient potential. You can say generator potential, but we are not concerned about generator potential. We are more concerned about the action potential, that how action potential works. Now here I have shown you the magnified view of the axon. Now suppose this is the axon. Now our body, it contains various types of ions, and this transfer of ions, it generates the electrical impulse. So you can say our body acts like a battery. We don't have electrons, but we have positive and negative ions. So this transferring of electrons outside and inside, it generates some signal. So how the signals are taken? Now let me tell you that inside the neuron, that is always negative. Outside the neuron, that is extracellular fluid, that is always positive. Now why it is so? Because outside there is a sodium ion, there is a chloride ion. Sodium ion, that is in excessive level, while inside there is a potassium ion, there is a phosphate, there is a protein, or you can say amino acid. Now this, you will say that potassium is a positive ion. Then why inside is negative? Because of the protein, because of the phosphate. While outside there is excess level of a sodium. So that's why inner side is negative as compared to outside. And you can say when there is no signal, the cells are at polarized, at resting stage. This resting membrane potential, suppose you can say resting membrane potential, that is minus 70 millivolt. Now what is volt? You know that how battery, electrical signal, it has some potential, and that potential is measured in the voltage. So you can say suppose minus 70 is a resting membrane potential of neuron. We are taking average. Okay, each and every neuron has a different resting membrane potential. But on an average, you can say minus 70 is a resting membrane potential. So it is at resting. Once the stimuli enters into the axon, what happens? There are ion channels. Here there are ion channels. So this ion channel is open, sodium channel. And that stimuli should be strong enough that it should convert minus 70 millivolt into minus 55. That is called as threshold potential. Once it has reached the threshold potential, sodium channel will open up, sodium ion will enter inside. Okay, that is called as depolarization. It will enter till the potential reaches plus 30 millivolt. Once it has reaches plus 30 millivolt, sodium channel closes and there is an opening of potassium ion. Potassium that is inside, it will move outside. Here you can see it will move outside. So negative charge will go outside. As it is a positive ion, as positive from inside, it is moving outside. So that is called as repolarization. Here there is a movement of sodium ion, and here this is the inward movement of sodium ion which causes depolarization. Outward movement of potassium ion after plus 30 millivolt, that is called as repolarization. And then it comes back to the hyperpolarization. If your potassium channels are open even after minus 70 millivolt, so there can be hyperpolarized, then it comes back to the resting membrane potential. Okay, now you will say that sodium is still inside, potassium is still outside. So there is a pump which is called as sodium potassium ATPase pump. Now this pump, how it works? It will throw out the sodium, 3 sodium ion, and it will bring back 2 potassium ion. That is called as sodium potassium ATPase pump. And again this part of neuron, it is maintained, it comes back to its normal position. Okay, now that part which is excited, and once the action potential reaches the resting membrane potential, this is at refractory period, and excitation, it will move forward. And same thing happen here. There will be opening of ion channel, sodium channel, which will cause depolarization. Then closure of sodium channel, opening of potassium channel, potential will move outside. There is a repolarization. Come back to the resting membrane stage. Activation of sodium potassium VTPS pump to store back the normal ion level inside and outside, and this will move forward. This will be at refractory. So signal won't move back, it will move forward. Okay, and this is how it reaches to the axon and terminal. Now